Yeah, I can see it.
Okay, so currently a Jack file is loaded, and then it goes through a
All
bunch of
the passes.
passes, right?
Okay.
I guess
Then
we can do dot dot dot, and then your caching your caching happens after a pass. What's the
yeah,
and what's
after
the
all the pass.
all is that in compile?
Uh, yeah,
So basically, there's a compile function, and you're caching the output of that function, essentially, or at
yeah,
least the output IR of that function.
yeah.
Okay.
We are caching the IR.
So this is, let's call this fuse pass, right? This is fuse, and
Okay.
then there's the AST gen, right? And then we've got bytecode gen. Okay.
Okay.
So it's before these two, and then you can run it, right? So then you have Python bytecode, right? So
Okay.
basically, you're caching at this point.
To be honest, I was checking the cache stuff. Okay. With Jack check. Okay. So what Jack check is doing is doing all the passes uh, till the type fusion. Okay.
Okay.
It doesn't continue after the type fusion.
Sure. Yeah.
Okay. So what my approach do is like it um, after all the process is completed, okay,
Mm-hmm.
it will save the IR.
Okay.
Okay.
And so this
I-
is the
I'm saving.
IR as it exists in this state, right?
Yeah. So when we do like Jack check, the IR
Mm-hmm.
will be saved after fuse. Okay.
Mm-hmm.
If
Sure.
we did did like Jack run, I guess it will be saved after like generating the Python code itself.
Okay. So or here when it's Jack
Yeah.
run.
Yeah.
Okay.
Okay. Can you
And you're
give
using a checksum
one
on
second?
the.
I will get my charger. One
Okay.
second.
Yeah. I think what we need to do is have a record replay
Okay, I'm
type
back.
thing.
Can you hear me?
Yep, I'm here. Yeah, I'm here.
Okay. So what I was doing is like saving the IR. Okay. After a compile finishes.
Yep.
Okay. So what compile do is like it calls like it gets a Jack parser. Okay. So Jack parser will get like a pass. This pass will be the output of like parsing the Jack file itself.
Mm-hmm.
Okay. Then it will call all the schedulers inside this IR. Okay.
Yep.
So what I do is like saving the IR after all the schedules are finished.
I understand. I understand. I understand. I understand. Honestly, let me talk about something real quick. So,
Okay.
let's just git stash this. You can still see my screen, right?
Yeah, I can see.
I'm on main. Let's see. Okay. So let me see. Let me see. Let me see. Ba, 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 ba. So you see this transform. This
Yeah, I can see.
transform, yeah, it has an input IR, and then it has IR as the state after a transform.
Yeah,
Now, like I'm just thinking on the fly, like, oh, by the way, there's a settings.py. Um, so so basically, like fuse type info debug. This settings.py allows you to use a config file or like config.ini in jacklang in a hidden directory called jacklang. So you can set these parameters either in a config file or in an environment variable with jacklang
Okay.
underscore. And so you can just import settings. This is settings, right? You can import
Okay.
settings anywhere in the project, and then you can load. Then you can like
Okay.
check these flags, right? So you can imagine a project wide setting that's for cached IR. You know, cache IR equals true,
Okay.
and then perhaps in a function. This is a base class for. So if you look at the classes, right? These are
Transform is the base class for all the passes.
for all the passes, exactly. It's a base class for all the passes, and it takes in an IR, and it essentially outputs an IR. That's kind of the functionality of the pass. This would be one place. Another place is IR pass.py. So pass is a base class of transform, and this has a little as some. This has the walking functionality basically, where you can walk trees and stuff. So maybe in transform, I wonder if there's a general way, because we have this jacklang home directory now, right? So like if you go to your home directory, you could do cd tilde jacklang, and then you can have files here. You could imagine also having a cache directory here. And I wonder if there's a general way that this class can check to see if cache is on, and then be able
Okay.
to have some kind of generalized way of you can imagine it can check.
So what you basically want is like, so for each pass
Yeah,
it will save like a cache file.
yeah,
Okay.
representing that
For each pass.
pass. Yeah,
Is that correct?
yeah. I mean, this would be one kind of basic way where the cache file could be named. It could have the name could be the checksum. I don't know. Like, so anyway, that's where I start thinking about this. I haven't thought through it, but I'm just wondering: is there, because Python uses timestamps to do its caching. So there's checksum, there's timestamps, there's I don't know actually. I'm just wondering what would be. I can think of the design from there. But the cool thing about that design is if your input IR checks out, then your output IR could be loaded directly from the cache. And then that object is then returned. So it could give you this really, really generic. So it's like almost like these would then have cache load or something like this transform could have like a cache load function or something. That's where my thought process starts. You know what I mean? So that way it doesn't matter what schedule, it doesn't matter where you want to pick up, as long as it's like you can kind of treat these as like pure functions or something. A pass is some kind of pure pass where if the input IR, like maybe input IR is generic T, but a pass, well, what is this T? T is bounded by something? I don't know. T is not bounded by anything. No, T is bounded by AST. Oh, cool. So this T is bounded by AST node, right? So basically, if on your AST node, it can have every AST node could probably have a function that produces a checksum like unparse. Like you could use unparse for now. Like maybe there's something like dot checksum. Maybe you add like a checksum method here, and so you can checksum
Okay.
the subtree checksum. where it can checksum itself, and then if it's good, you know, you can check that maybe on that AST node, the T,
Okay.
and then in transform. So maybe there's something like that. So I'm just talking through it live, but think about that for a while, and then let's have another conversation.
Okay. So you want like to have like for each AST node to have like a checksum, okay, and in transform we will be saving like a cache for, for each transform. Is that correct?
Yeah. These AST nodes are like almost always module nodes. So just that's just a piece of information. These nodes are almost always module nodes, but and so you know, yeah, and Jack's source is a module is a AST node. So you can imagine even from the source level, like this could have like some kind of timestamp or checksum, some checksum function that all AST nodes have. Or I don't know what you call it, checksum, unique identifier, or state ID. I don't know, whatever you want to call it. But so even from the source, it'll be able to automatically give you the transform output. You know, it's kind of how I'm thinking about it.
Okay, so in transform, if we find like a cache file, so
Yep.
it will try to load it and it will compare it with
Exactly.
the checksum, and if the checksum is correct, then it will load this node instead of the current node, and if it's not correct, the transform will run on this node.
Yep.
Is that correct?
Yeah. So it's almost like it'll skip. So transform has this transform here. It's almost like it'll skip this transform and just load the IR from the file, unpickle it or something.
Yeah. But I have like I can see like there will be like some issues. So there is a big issue inside the AST nodes itself. So can you open schedulers? So the first one subnode tab pause. Okay, this one will save like a dictionary variable with all the module nodes, all the nodes of specific type. You got what I mean?
Yeah, I know what you're talking about. So it saves the dictionary in here. So I think transform is going to need to have it. Yeah, I understand. But you'll have to have an abstract method that is cache on cache or something with a default behavior, and then in some passes maybe you have to override it. I don't know.
Okay.
You know what I mean?
Yeah.
So yeah, I hear you. But just think through it, and as soon as you kind of think through it, call me and then we'll talk again.
Okay.
So yeah, and so like just for you, so you know like all of these are passes, right? So you can think of it as a transform, and then it has a pass, and then it's like, you know, the final my pass, right? So this is essentially the hierarchy of everything, and everything has this, right? Yeah. So I mean, I think that caching layer, like just the abstract class approach for it,
okay,
every pass has an input to output translation, and so basically input IR and then self.ir is the final output, but sometimes it might have it might have some other things like tables and stuff. When it does, it's almost like there's gonna have to be cache dump, cache load. You'll need to have a cache dump, cache load, so that the state inside the pass can be completely,
But I have like another question. So
okay.
if a source file is changed, So I
Mm-hmm.
expect that all the passes need to be like triggered again. Is that correct?
Yeah, yeah, yeah.
So why do we need to save like a separate cache file for each transfer? Okay. Even if a file is changed, all the transforms will be like called again.
Yeah, so if a file is changed, that would be the behavior, correct. But you can also imagine, like, you may compile a file once, but then you might need to, like, in a tree of changes, right? Like, some file might change, and then you need to compile this file again. You know what I mean? Or you need to run an analysis, like a type check. So then you need to run a type check again, and so you may want to detect that this module has changed, but these are the same, you know? So like when you run this module through, it would just fast track through with loads, right? But then this module wouldn't fast track. Like this one would actually go through the compile. Like there's situations like this, and
Uh,
you know,
I guess this situation I already like implemented it
I know.
when I did, yeah,
Yeah,
when
yeah.
I
Go
did
ahead.
the saving at the end. Okay, so
Mm-hmm.
at the end when I load like the main module,
Yeah,
okay, in
yeah,
the
yeah,
code,
yeah.
it will try to load all the sub modules. Okay,
Mm-hmm.
and if it found like a sub module that needs to be recompiled, so
Right.
it will do the recompilation again in all the AST.
Sure.
Okay,
Sure.
and there will be like a variable that if this variable is set to true, it
Mm-hmm.
will do the pruning. It will prune the AST,
Right.
the transfer.
That
So
could,
it will prune the passive.
yeah. So that could have some high complexity. Yeah, I agree with you. I know that you've implemented pieces of this, but I think there's a number of reasons this is better. So one of the reasons is there is actually, like, you may not want to compile. There's so many transformations that happens through this journey. You may not want to like if you compile it once, you might want to do something else, right? Some kind of analysis, like I don't know, auto format or something, or some other kind of analysis where you don't, yeah, where you don't want to, like, yeah, because this is destructive, right? Like each one of these is destructive. So having it at each place here could be useful because you may want to just get to a certain pass. Also, yeah, there's future roadmap too where we may be able to do this at. There might be a way that we can do this at some parts of the AST and not others. So the argument would be maybe there is a caching that you can do in IR pass where some nodes, like when it, I'm just thinking that there's a future roadmap where there might be elegant ways to get fancier types of caching, in the thing. So I don't know. I haven't thought through it fully yet, but I do know that you might want to be able to go back passes to see what's going on, what errors came from here maybe, and what errors came from here, or run this analysis again on a whole big tree, but really only one file changed, stuff like that.
Okay. Okay. So I get your point. So in transform we will have like a functionality of like dumping cache and loading cache. Okay.
Mm-hmm.
And this will be like an abstract methods that
Mm-hmm.
needs to be implemented by each pass.
Yep.
Okay, so each pass need to like implement these methods to
Yep.
load and save the caches. Okay.
Mm-hmm. Mm-hmm.
Uh, and okay, I got this point. So there was like another point. So inside the AST itself,
Mm-hmm.
you want to have something to calculate the cache or something like this.
Yeah, I don't know
So
how that looks like yet. I don't know how that looks. I know that there's timestamps and checksums. I mean, I'll let you like that should be. We should try to implement this stuff in a very modular way where that's why I was like calculate checksum, and then maybe you can actually do a checksum on the on parse. You might be able to do that, but there might be some other things you can do from the file itself. That's saved. So so just whatever works. You can get functional now, and then we can optimize later.
Okay.
No.
Okay, so I will focus on the first one
Okay.
of like adding the dump cache and load cache and the
Mhm.
transfer.
Mhm.
Okay.
Mhm.
And after finishing this, I will focus on how to calculate the checksum efficiently.
Yeah.
Okay. So the way I calculate it right now is like in module, in
Mhm.
module AST, there is function to try to like generate the drag code again from the AST.
Yep.
Okay, so I was using this function to
Yep.
get the drag code, then I was hashing it.
Yeah. That might be fine for now. That might be fine for now, but that's actually gonna be. It'll be slow for now. Yeah. Go ahead.
It is slow, and if I change it like the the doc string of a function,
Mm.
okay, then the checksum will be changed.
Mhm.
Okay, so there are like some cases that the checksum will not be accurate, even if the changes is for like comments or a doc string.
Yep.
You get what I mean?
Yeah. I get what you mean. I mean,
So
yeah.
I was thinking how to like bypass this, but I was like leaving it to the end. I was
Sure.
focusing on to make it like working. For
Yeah, exactly. I think that's a good approach. I mean, one thing that comes to mind is I think you always have a jack source, and this will always be attached to a module. Perhaps the jack source, you can do a checksum on the jack source. Is
Yeah,
possible.
I was thinking about this one,
And because jack source is always in the module, so yeah, I mean, definitely, yeah, you could think about it. Where is it, jack source? Right here. I don't know. We can come up with a solution to that as a separate problem. So getting it to work first is completely reasonable.
Yeah. Okay.
Yeah.
So I will work on it and
Yeah.
I'll update you once I.
Yeah. Slack.
So
Yeah.
there, I will create like another branch.
Okay.
Maybe call it like
Mhm.
Jack Cache 2 or something like this.
Yeah. Sounds good. Sounds good, dude. That's good. That works for me.
Jack
Yeah.
Cache, Jack Cache version 2. Okay.
Yep.
And inside it, the first commit will be like the changes inside the transform
Mhm.
with the abstract function inside the buses.
Mhm.
Then I will start changing the buses or implementing the dump cache and load cache
Yep.
one by one
Yep.
in the buses.
That sounds perfect. Awesome. And keep me posted. I'll be more available now too because I'm back.
Yeah.
So just slack me as you go. Slack me as you go. Let me know. Let me know how it goes, dude.
Okay.
Yeah.
Sure.
Yeah.
Okay.
Awesome. All right, man. Cool.
Okay.
Yeah. We'll talk soon. Yep.
Sure.
Yep. Later.
Bye.
Bye. All right.